All right. So, system design for everyone, a guide to building highly efficient applications by none other than Rising Odegua. I think the clicker is it with you?
Hello. Hello. Hi. Good afternoon, everyone. Hope you can hear me clearly. Okay. My name is Rising Odegua, and let me see if my slide is up. So some brief introductions before my slide comes up. My name is Rising Odegua, and I like to call myself a full stack engineer. I know lots of people say there's no such thing as a full stack engineer, but I've seen lots of full stack engineer, and I am one of them. So there are full stack engineers. But these days, I also like to call myself a product engineer because I can work across multiple stacks. Okay, so that's me. I currently work at a company called Nosa Data. It's a data company. We do lots of amazing and exciting stuff. I do lots of open source, hence I'm here. I don't know if anyone has used the package downflow.js or if you've heard of it. I was one of the co-creators of that package. I also have lots of Python packages as well that I've worked on, and I just like to build stuff. Okay, so that's me, and that's the reason why I'm speaking on this amazing topic, which I like, called system design, because it's going to talk to you how you can actually architect an entire system from the front end, the back end, the development, the scaling, and everything into an entire system design. Okay, so that's why I titled it System Design for Everyone. Just waiting for that to load up. Come on. Okay, so what are we covering? We're going to cover what the system design is. We're also going to talk about building for one user and then scaling to millions of users. Because when people build their product, most of the time, they start with a single user. They start with 10 users, 100 users. And then with time, you start thinking about millions of users. So we're going to talk about how you can build for one user and then you can scale to millions of users. And then some time for conclusion and Q&A. So quickly, because I have just 15 minutes, which is not enough to cover this topic. This is a very broad topic. And for those of you who have done interviews for senior positions, this is something that you must do as part of your interview. Because when you get to a certain level, you are not just tested on your code skills anymore, because almost everyone can code well. Okay? So you get tested on something called system design. Is your ability to be able to picture an entire system, how it is built, how each component interacts with each other. In that way, you stand out from your fellow other programmers, because if you just know about the code, you are limited. You need to know how every entire system or every entire component interacts with each other. Okay? So we define system design as a process of, we define the architecture, components, the modules, all the interfaces, and the data for a system to satisfy the requirements of a system. Okay? That's the entire definition. And then we say that a well-designed system should be efficient and highly scalable, meaning even if you are bidding for one user, if your application, for instance, goes viral, is it resilient enough? Is it efficient enough to scale? Or is it going to break down? I've heard lots of stories like that where people spend weekends building MVP and then it goes viral, gets hit by lots of users, and then it's not scalable enough. It crashes. I mean, there's a story not too far from us here, which is this past election. We heard that one of the cases was that the system went down because of too many users. I'm not going to comment on that. But yeah, that's just one of the reasons why you should design your system properly. So it should also be reliable and robust, should be easily maintainable, so other engineers should be able to come into the system and be able to make changes or add updates as well. Also, it should be interoperable, meaning it should be able to work across multiple components or multiple operating systems. It should also be cost effective. I'm going to rush this now because time is short. So let's see, building for one user and scaling to millions of users. Now, when you are building an application, the first thing you talk about is you have a server somewhere. You have a server somewhere. So you have your web server, you have your database, everything that you need, all in a single server or in a single instance. Everything is running from one single block. And then you have your client who accesses your application to that single server. So you have maybe your React application, your fast API backend, everything running and being deployed on a single server. So what happens? Client goes to your application, puts in your URL, they come to your web server. Sultan talked about IP and how the internet works. Basically, that's what's happening here. You spin up a single server because you're trying to start small, and then you have that being used. Now, there's one big problem here. If this is your entire setup, there's failover that can happen. That means if your single server goes down or something happens, your application is cut off from the internet. So there's high probability of failover. So most of the time, we don't use a single server that houses both your server and your database, because something can go wrong with your database, and because of that, your server goes down. Or if something goes wrong with your server, because of that, you can't access your database. Okay? So how do you handle this failover? So let's start from separating out the database from the server. Come on. Yeah. So the first step we do, because we are trying to design an efficient system, okay? So we take out the server and we take out the database, separate server for database, separate server for our web, okay? Now, in this case, we've handled one important issue, such that if the database goes down, you still have access to your web server. Maybe you can have some backup there. Okay? If your server goes down, although you have access to your database, you still cannot access it. But you've solved one important issue. There's no failover because you've separated these two components, which is very important. That's why most of the time people deploy databases separately from their web server. Okay? So that's one step. So you can see we're going to be gradually building on top of this. And then you see how the entire system looks at the end. Okay, so we separate the database. Come on. I think I missed one. Okay, I did not. That's fine. We've taken care of the server, separating the database. And now we can do something called scaling. Okay, so there are two types of scaling. We have vertical scaling and horizontal scaling. So you can decide to say, okay, I want to scale my database in two different ways, or I want to scale my server in two different ways. You can add more power to your server. How do you add more power to your server? By spinning up a bigger RAM, adding more storage, giving it more CPU. If anyone has spinned up a server on AWS or Amazon, you know there's like a UI where you can select the memory, select the RAM, and all that stuff. Now, if your server is too small, if the workload increases, you can have failover issues. So what you can do in that case is to spin up, make it bigger, increase the size, or increase the RAM, and that can help. But this is not the recommended way of scaling up a server. Why? Because there is a hard limit. Because you cannot add unlimited storage. There's no unlimited storage in the world. So there's a hard limit to how much storage you can add to a single server. So most of the time, we do what is called horizontal scaling. We scale out. That's why you hear about things like microservices. Where you spin up multiple instances. So you can spin up as many instances as you want, and that can actually help you to redirect traffic to all these instances. Okay? So horizontal scaling just means adding more servers. So you can add as many as you want. It's great when your traffic is high and the app needs high availability, but it's also harder to manage and maintain. Okay? So let's see how our architecture is going to look if we use horizontal scaling. Come on. All right. So now we have, instead of a single server, we have two servers. And we added a new component called a load balancer. Now, from the name, you can tell what it does. It basically balances traffic between these two servers. And the two servers are doing the same thing. They are serving the same traffic. But maybe the load balancer can send 50% of the traffic to one of the server and the other 50% to the other one. Now, what happens if one of your server goes down? The load balancer will automatically redirect all the traffic to that one single server remaining, and to try to spin up a new server to take up the dead one. So you can see this is now resilient, because if one goes down, you still have another one that you can use in that case. So we've horizontally scaled our server. Now you can add as many new servers as you want based on your usage. So you hear something called elastic scaling. Most cloud providers give you something called elastic scaling, whereby you can have 2, 3, 4, 5 servers if your traffic is high. Once your traffic is low, you scale in, and then you reduce the number of servers so you don't pay more for that. Okay? So that's horizontal. So you can see our system is building up on each of these layers as we go. Now, that's the server layer. So now let's talk about the data layer. How can we make it resilient? Because at the moment, we've taken care of our server. Server is fine. We've horizontally scaled. What about the database? If you have just one instance of your database, what happens when maybe there's a fire outbreak, or there's thunder, or anything happens to your database? What if you lose your data? Because you have just one instance running, you lose everything. Okay? So the most important way you can take care of your database is to do what we call database replication, whereby you spin up multiple instances of your database. You have one or two called the primary database that is going to accept all the write operations. So once the user creates new content, you write to that database. That is the only function of the primary database, just to receive writes. And then you get replicas, multiple databases, depending on what you are serving, the kind of traffic you are serving, that will handle just your read operations. So because they handle just read, it's faster. And also, your data is redundant, meaning you replicate it among multiple instances. Now, if your primary database goes down, I think my time? Oh my God. If your primary database goes down, you can easily promote one of the replica to become a primary database, and then you spin up a new one. Now, you don't do this manually. This is done automatically, okay? So, in this way, we take care of our database and make it what? Resilient. Now, we've talked about taking care of the database, taking care of the server, using horizontal scaling and all that. How can we improve load and response time? Because if your functions or if the things you are trying to do in your server takes a long time, no matter how many servers you have, it's still going to be slow. So there are ways you can improve your load and response time using something called a cache. Don't know if you guys have heard of it. I'm sure you have. So it's just a temporary storage that stores expensive responses or frequently accessed data. So for instance, if users are trying to load a web page that contains a particular content, for instance, and maybe lots of users are trying to load that page, you don't have to go to the database every time to get that content. You can cache the content so that when someone requests for that same information, you just return it quickly without going to the database. So you add an extra layer in front of the web server. So once the load balancer, once a user makes a request to your server first of all check if it's in the cache. If it's in the cache, it just returns it instantly, super fast, instead of going to the database. In that way, you increase load and response time. Now, that's on the server layer. Now, you can also add cache on the client layer using something called a CDN. So a CDN is just dispersed servers around the world that helps you cache static content, so like images, videos, JavaScript bundles, and files, so that the closer you are to a CDN, the faster you get information. Now, if you're trying to load a website from here, and the server is in, say, San Francisco, for instance, it's going to take longer for an image to travel from San Francisco to you in Nigeria. But if there's a CDN close to you, maybe there's a CDN in, say, South Africa, for instance, instead of going to San Francisco, the server will redirect you to the CDN in South Africa, and that will return the content for you in a faster way. Okay? So that's cache on the client side. I'm just going to rush this now. So you can see we have another layer, CDN. We still have our cache on the server, which handles all that. And then we can take it further by separating our state information from our server. Now, if one of the big issues of having multiple servers or managing multiple instances is that you have to manage something called state. Because if you have 2 servers or 3 servers, for instance, if a user goes to your application and the load balancer redirects them to server 1 and they authenticate, if they go to server 2 does not know who they are. So you might ask them to re-authenticate, and that's not a good user experience. So it's always good to separate your state information out of your instances. 2 minutes, okay. Yeah, so this is the preferred method when you are working with multiple instances, whereby you have something called a shared storage that all your instances use to access state data. So if you authenticate a user, you save it in the shared storage, and all the servers can access that shared storage. So in that way, you can scale the shared storage independently, scale your servers independently. Now, this is our architecture. We now have the cache sitting in front of the database. We took out our state, and we now have a shared storage. Okay? So we are building on top of that. I have to rush this now. Another thing that is important is to decouple something called long-running operations. Now, what is that? If you've used applications whereby you do lots of processing, maybe I think there are some nice AI applications whereby you upload your photo and then it turns your photo into some nice characters, right? Sometimes it takes like 24 hours, 6 hours for it to get done. What happens is that once you submit your task, they push your task into something called a queue. Okay? So that queue has consumers. So what happens is that once there is enough resources to service your request, it's going to pull your information from the queue, run that job, and then inform you that the job is done. So if you have long-running tasks, maybe you have big models that have to make predictions, if you're an ML engineer, you can push that into a queue, and then you can send requests to that particular queue. I'm just going to be fast at this point. So we can add another layer whereby we have a message queue. Once the server receives the information, it goes to the message queue. If these are long-running tasks, it sends those tasks to the workers. Once the workers finish the information, they can probably write to the database or tell the server that they are done, and it can send the information back to the user. We've gone another step further. Now, if you want to make things complicated, or you want to be very, very, how will I put this, resilient, you can do what is called multiple data center setup. I don't know if you have heard about US East 1 going down. DevOps guys, US East 1 is a very popular data center. Once there's an issue, lots of apps stop working because they deploy in that data center. So what you can do to make your app more resilient, depending on how critical your app is, you can do multi-data setup, whereby you spin up your entire application in different areas across the globe. And then you have a load balancer that does what is called geo-routing. So based on your location, it will redirect your request to a particular geography or location. That's multi-data setup. So conclusion, not do past yourself. Try to be as simple as possible. You don't have to build all this into your application. If you have an MVP, start simple. Single server, that's enough. But the idea of this talk is that you should have this at the back of your mind, that if you want to scale from 1 to millions of users, you have to start thinking about these different components. This is mostly done by the CTO or the architect of maybe a startup or a company. But it's good that you have this knowledge as employees. So this is the real conclusion, not the other one. I'll share my slides as well. Thank you very much for having me.